Welcome to the lecture on environmental impact of the energy industry. And in this lecture, we will study how renewable energy sector, in particular solar and wind energy, affects the environment. After this lecture, you will learn about the negative side of renewable energy, how to reduce the negative impact, and why renewable sources are still better than fossil fuels. There is a strong belief in our minds that renewable energy is safe and environmentally friendly. Indeed, renewable energy facilities don't produce smoke, don't require fuel, and don't increase radiation levels. But does this make them completely safe for nature? The climatic aspect of renewable energy development is connected with zero carbon production at solar, wind, and other power plants on renewable sources. In these cases, energy is generated without burning hydrocarbons, and as a result, without releasing greenhouse gases and other pollutants into the atmosphere. Therefore, renewable energy is clean and has no such impact as the use of fossil energy sources. However, the situation is more complicated if we consider the whole life cycle of production, starting from the preparatory stages and including the process of energy production. In previous lecture, we have already considered the impact of hydropower and bioenergy, which are related to the renewable energy sector. Now we will study the environmental impact of wind and solar energy. Consideration of environmental impacts at all stages shows that the transition to renewable energy doesn't always lead to a reduction in environmental pollution, including a reduction in CO2 and other greenhouse gases. To obtain energy, it is necessary to manufacture and install energy equipment, create infrastructure, and provide conditions for its operation. Prepare raw materials and dispose of used materials and equipment at the end of its life. This requires the work of metal industry, mechanical engineering, agriculture and other enterprises, the use of energy from fossil sources, and means non-zero emissions. This picture shows a comparison of the carbon footprint of different areas of energy. As we can see, compared to traditional energy sectors, the renewable energy industry has a small carbon footprint. CSP in this picture means concentrated solar power, and PV means photovoltaics. If we look at solar and wind energy in details, we can see that most of the CO2 emissions occur at the construction stage, and concentrated solar power has the largest carbon footprint. The important point is that unlike thermal and nuclear power plants, solar and wind power plants compensate for emissions throughout clean energy generation. Another possible environmental impact factor for wind turbines is the death of birds. The study of interaction between wind turbines and birds has found that wind turbines scare the birds away, disturbing their nesting and feeding places. The blades cause injury leading to bird deaths. However, most of the data obtained indicate a negligible number of bird deaths in comparison with other elements of anthropogenic impact. For example, collisions with houses and skyscrapers kill thousands of times more birds annually. But now studies to prevent impact on birds are also conducted in order not to increase the negative impact on the nature. There are meteorological approaches to reduce potential impact both in the planning and operational phases of the wind power project. The model simulates bird migration and quantifies the risk of injury. It is necessary to carefully select the location of wind turbines, avoid migration routes of birds, most common feeding and nesting places. Use modern wind turbines whose blades rotate slower, which reduces the probability of collision with birds. One of the main arguments against using wind turbines is noise. Sound can affect people as well as disturb animals and birds. Now scientists actively study the mechanism of noise generation to control it effectively. Methods of calculation and prediction of noise level from wind park are developed and validated experimentally. Modern numerical simulation methods allow us to predict and optimize the possible noise level with high accuracy. Turbine manufacturers consider noise as an indicator of inefficiency, so we pay increased attention to this aspect. In the industrial wind energy, the noise limit is 45 decibels at a distance of 300 meters from the wind turbine. Distance of 300 meters is given as the minimum standard in most countries of distance from residential buildings, and the noise level of 45 decibels analysts compare with natural noise at night. On average, it is from 20 to 40 decibels. At 1.5 kilometers distance, noise becomes inaudible. A number of people report environmental sensitivity to infrasound characterized by the presence of recurrent non-specific symptoms. The causal relationship between the effects and symptoms is not supported by empirical evidence. Studies show that symptoms can be explained by a nocebo reaction, in which health problems and negative expectations created by social discussion and media reports cause symptoms. The potential environmental impacts associated with solar power are land use and habitat loss, water use, and the use of hazardous materials in manufacturing. As we have seen before, the environmental impact of solar energy varies depending on the technology, photovoltaic solar cells or concentrating solar thermal plants. Solar power plants require a lot of land, 8 times more than thermal power plants, to produce 1 kilowatt of energy, and often it is the land where flora fauna live. If it is not possible to change the habitat, some species may be affected. On average, land area requirements for solar thermal plants is higher than for photovoltaic systems. Unlike wind facilities, there is less opportunity for solar projects to share land with agricultural uses. However, land impacts from utility-scale solar system can be minimized by siting them at lower quality locations.